Part 2 of the simple stormwater drainage network. Since we have our inlets, our manholes, our conduit, and also our drainage areas set for our design, now we can go through the computations and see if our network performs like the way we want it to, hydraulically. So that's what we will be going over next. We'll talk about the compute center, we'll talk about flex tables, where you can analyze your network looking at through a table, and then we will also look at the profile runs. That way you can visually see the water going through your drainage network and see if there's any problems with it. First thing that we will do is go to our Analyze tab and select the Compute Center. And under here we have some different design scenarios. And these are based off the rainfall events that are set up in the EPG for doing stormwater drainage design. And you'll see here it's broken out by districts and also the year of the storm event. Now there's also two different types that you're going to see. You're going to see an analyze and you're going to see a design. Now these two do two separate things, and this is very important. If you do an analyze, what it's going to do is basically take what you have placed in your stormwater drainage design and try to analyze it. It's not going to do anything with your design that you have set. So whatever size pipes that you placed in there, whatever inlets, whatever depth that you put them, it's going to stay exactly the way that you have placed it. So if you just want to analyze your design to see how it functions, that's what you'd want to do. Then you have an option where you can do a design, which basically what it will do there is take what you have and make it to where the application will set your elevations and possibly size up and down your pipes to get the water to flow efficiently through your network. Now, what I normally do with this, if I'm going to do a design, I would probably do a file save as and save this file as something else and utilize that and run a design in that separate file. That way, if I have everything pretty well set in the file that I'm currently in and I don't want to mess anything up, that's whenever I just do a file save as, save it as a separate file, and then run a design and see what it does. And then you can always go back into your original file and adjust things accordingly. That's the way I would do it, but if you want to do it a little bit differently, you can. For this example here, we're going to do a 25-year event, Central District base analysis. So I'm going to select that particular storm event. And it goes through there and it copies out what it needs to do the computations for it. Now if everything's ready to go, all we simply need to do is click on this button right here that says Compute. And what I have here is I have some errors. And this is basically what you'll get if it doesn't have enough information, or if there's a bust in your drainage system. This is what you would get, is an error. It doesn't have enough information in order to process your design. So it says right here, we have a couple different things. We have no gutter leaving the on-grade situation. The bypass flow will be directed to the sub-network outfall. And basically what that one means is, let's say you have multiple inlets. Any bypass that goes past one of those inlets, it automatically gets put to the outfall, which theoretically it should get collected to the next node downstream. So we'd have to put in a gutter for those, and we'll do that here for this example here in a second. This one right here, and this is where our error is at. If you see this, the one in red right here, gutter shape is invalid. Perhaps the catalog gutter reference is not set or no longer exists. So we need to go to those particular inlets and place the proper gutter. You can come in here and click on OK, and you can actually right click over the one that's in red and do a zoom to, and it will somewhat zoom you to the actual node of where the error occurred at. So this one right here is one that has an error on it. So I will go ahead and close down my compute center since I need to fix a few things, and I will go ahead and select this node, and I will get to my utility properties, and if I scroll down through here, we're going to see a gutter catalog. This is what we need to change. So I'm going to change my gutter shape to V shape, and that's what we have all of our gutters set to. And then for my gutter catalog, My curb and gutter for this particular drainage design is curb and gutter type B. So I will go ahead and select it. And you see that it sets all these attributes right here. And these can be changed, but you'd have to go up to your gutter catalog and change those accordingly, which that was demonstrated in a previous video. So we have that set, and we'll leave all these attributes set the way they are. Now we can go ahead and do it to the remaining ones. So we know we have this one here set. We need to do it to this one. That one there's good. And I will go ahead and do it to this one here. And you notice that I'm not closing out this dialog box. I don't have to. So I can simply, once I have one set, I can go to the next one and I can keep going to make my modifications. Now that I have all those set, the only other thing that I'm going to do now is actually put a gutter from this one right here to this one right here, because I don't know if this inlet is collecting 100% of this drainage area right here. So I want to make sure I put a gutter going from this one to this one, just in case there's any bypass flow getting past this node that it's going to try to collect it downstream. So I will go to my layout option and I will use the place gutter, and I'll select yes to this. And on this one here, I'm going to use between nodes, and for my feature definition, I'm going to use curb and gutter type B. Now I will place that gutter. My start node, and basically I want to try to mimic what my gutter line is. That way it calculates it properly. So I will go ahead and select this point right here. And I want to go in the direction of flow. And I will go ahead and select it at this point right here. And now my gutter is placed. I can go ahead and right click to reset it. I don't have to do it to these remaining ones because basically they're being treated as a sag inlet. Now if I knew these were in a sag, I would change these from on grade to sag. But this is theoretically not in a sag situation, because this water here is not being collected here, so it could bypass this and go around and be collected to some other node downstream. So I'm not going to, for this example, come into my hydraulic properties here and change this option from on grade to sag. I'm going to analyze and see what it does first, and then if I have to adjust it, I can always adjust it accordingly. But if I knew this was in a low point or in a sag, I would definitely come back into my utility properties and change this option from on grade to a sag. That way it calculates it a little bit differently. So let's go ahead and close that down. And I will come back in here to my view attributes. In this use analytic symbology, I will go ahead and turn it off now. So now let's try to analyze this and compute it again. So I'll go back to my compute center. My 25-year event is still loaded, so I don't have to do anything to that. And let's go ahead and compute it. And if you get this right here that says convergence was achieved, it had enough information in order for it to analyze and do the hydraulic analysis for your stormwater drainage network. Now there's some things that you may need to change, but it had enough information in order for it to compute it. So now we can come in here and kind of look at some of the stuff. We can go to our details, and we'll look at some of the catchment summary, what it's doing. We can look at the link summary, what our links are doing. We can look at our nodes. We can kind of look at all this information as a summary and kind of see what's going on. So that's one thing that you can look at for your summary. We can go ahead and close that down. We can close the compute center down. Another thing that we can look at is the flex tables. So if I come in here and select flex tables, hydraulic analysis, in here we can come through here and look at some of our tables that are set up. So if I want to look at my inlets, I can go to my catch basin report, and I'll double left click on it, and you'll notice that it has some options through here. These right here, the ones that are in white, you can actually edit those numbers and it would reflect in your design. So that is an option for modifying your design. You can come in here and modify these accordingly and it would reflect in your design. That's just one way to modify your drainage network. And you can look at some of your inlets here to see how much it's actually being efficient, how much it's actually capturing. And this is the stuff that you'd have to look at and say, okay, it's collecting 100%, there's no bypass, you're good. There's nothing going to be collected downstream. Now, if there's stuff that's being missed, maybe it's going too fast or there's too much water going into that inlet and it needs to be collected somewhere downstream, that's whenever you'd have to come in there, possibly add another inlet, or maybe the actual existing structures that are out there, maybe it can collect the remaining amount. So that's just stuff that you would have to look at for your drainage network and adjust it accordingly. So that's the stuff that you can modify using the flex tables. And you can look at different tables that we have set up and see what's going on, as you can see right there. Now, one thing that we did forget in part 1 is the time of concentration for your drainage areas. But by minimum for a stormwater drainage network, it's 5 minutes. And these are all below 5 minutes, so that's why it's still set to 5 minutes. Now, if you had a drainage network that's a little bit longer duration, say it's 7 minutes or 10 minutes that it's trying to get to a particular node, then you definitely need to go in here and select one of your drainage areas and get to your dynamic toolbar and go to utility properties and change your time of concentration to whatever it needs to be. Keep in mind that it is set in hours. So if it's 10 minutes, of course, that would be 0.16667. So just kind of keep that in mind that it is in hours. So we'll go ahead and close out of that. The next thing that we're going to look at, since we looked at the flex tables, you kind of have an idea of what is inside of there and your compute center. Next thing that we're going to do is a profile run, which will give you kind of a visual of the water going through your network. So if we go back to the layout tab, and we will select the one that says hydraulic run from node. So we'll select that, and I will select this one right here since this is basically my start location. I will select it. And basically you'll see the run that it's going to try to go to the outfall. And if that's what I want, I would go ahead and select it, but I will change my feature definition to linear design miscellaneous drainage profile run. That way it puts it on the correct feature definition and I can easily turn it off later on. So once I have that, I can right click to accept, and then I will go ahead and left click to accept the profile run. And now it's complete. And to visualize that, we'll go to the Explorer, go to Drainage and Utilities Model, and we'll expand this out. We will go to the profile run, and over the profile run that you created, of course you could have renamed it as something else, but over the one that you created, we can come in here and we could rename it from here. We could delete it if we wanted to, or you can open up one of these models. And the one that we're going to look at is the Open Analysis Profile. So we'll left click on it, and inside of here you can see how the water is flowing through your network. Now you'll notice on this one here that we have kind of an issue. On this particular node here, it's a lot farther down than the other one, and maybe I changed something in there to make that change. So this is where you'd have to come in here and modify your particular design to get it to flow the way you want it to. So we'll go ahead and close this down, and we will make modifications to this design to get the water to flow correctly through our particular system. So if I want to look at that, let's go ahead and select F6. And I'll go to view number 2, make sure it's highlighted. Now I'm going to use my rotate option, and I'll go to one of these nodes here. You'll notice that this node right here is deeper than what this one is right here. So that's why in my profile run, that's why I'm getting this big dip right through here, because this node right here for some reason was set lower than what this one is right here. And theoretically the water should be going from here to there to there to there, and of course to the outfall. So that's where you'd have to come in here and adjust this one right here, or we could adjust this one right here to be a little bit deeper. That way all the water flows the way it should. And like I said, that's just stuff that you would have to look at and change per your drainage design. And we'll talk about that in part 3 on modifying and changing some of your designs and stuff that you could possibly look at. So we will go ahead and close it down. So that's using the compute center, getting your analysis. Like I said, we just analyzed it from the stuff that we had, and then using the flex tables, looking at some of the options for through your flex table to see different numbers for your computations and how everything is working through your system. And then of course the profile runs, which allows you to visually see your nodes and the water going through it. And this one right here, of course, is your 3D model, and basically shows you those 3D objects and how your actual inlets are placed. Now, one other thing with this, I do have in view number 2, if I go back to the Home tab, and this is just a little tip here, if I go back to the attachment tools, I have the final terrain turned off. That way I can see my drainage design. But one little note here is if I come in here and I turn that back on, I will right click over this area through here, through my columns, and I'm going to turn on my transparency. And what I will do is actually apply a 60% transparency to that particular reference file. Now nothing showed up yet, but now if I go back into view number 2 and I turn on transparency, this is a nice little option to where you can still see your final terrain model, but then also see the stuff underneath of it. Kind of like a transparent piece of paper, you can see through it. That's basically what we're doing here. So you can actually kind of see your drainage network underneath of your roadway.